Awesome. Well, I'm really excited to kick off this webinar. Very nice to meet you all. My name is Alex Halliday. I am a venture partner here at SparkLabs and the founder of a company called AirOps, which I will be telling you a little bit more about today. Let me just share my screen quickly and get things moving. Great. So the topic of today's webinar is applying large language models. The goal here really is to try and understand how we can take advantage of this exciting new emerging technology in our products and in our startups. The space is moving so incredibly quickly that I think for so many of us, we are thinking about our product roadmaps, our kind of product strategy and where we want to invest and how we can take advantage of some of these models that are emerging that we'll talk about today, either to improve the efficiency of our operations, to do things 10 times cheaper, 10 times faster, or alternatively, to really think about how we can deliver fundamentally new experiences to our customers. I think I'd love to just kind of introduce myself quickly and then talk a little bit about the session today. So my name's Alex. I've been in startups for almost 20 years. Started my career as a founder in the social networking space, and then spent about 8-9 years in Silicon Valley building product teams in very early stage companies. So typically joining around the Series A and taking companies through to the Series C, D, and did that for a company called Masterclass, which some of you may have heard of, and then 2 marketplace businesses as well, one in the real estate space and one in the apparel space. And so I've spent my career kind of really in the formative moments of a company in its earliest stages, dealing with so many choices around technology and scaling, hiring teams, really understanding how to bring a product to market, build out the first product team, the first engineering team, the first design team. And so hopefully, like many of you, are really excited and energized by these early moments in an organization, and also so often kind of stressed and overwhelmed as well, especially with the last few days and everything that's been happening. But I think we're at a really exciting time right now on the technology front. For the first time ever, there is a real viable set of AI large language models that really do level the playing field in so many ways. And so I personally am very excited about this period and what we're all able to build. And one thing to say is, like, we're all learning. Even just yesterday, we saw a whole new host of announcements from the team at OpenAI, which we'll cover briefly. But I'm not coming to this call necessarily as the world's greatest expert at all. I have spent 14 hours a day for the last 3 or 4 months working on nothing but this. So hopefully I have some things to share, but would love to make this a collaborative conversation as much as possible. And if you guys have a moment now and want to just maybe just briefly introduce yourselves in the chat, that would be super helpful so I can see who is here. And would love to also spend some time towards the end of this just talking a little bit about maybe some of the things that you're working on in your own startups and some of the applications that you see for this new technology. So great. With that, let's jump in. So a brief history of how we got to this point today. It feels like progress was really slow for a number of years and then suddenly incredibly quick. So the kind of foundation of this new wave of large language models was set by Google in a paper they published called Attention is All You Need. And that really started this deep dive by various organizations, including OpenAI, into the world of large language models. Large language models are these large pre-trained models that are capable of, in many cases, working with text and code and problem solving. And they're fascinating because in many cases that all they are trying to do in their simplest form is predict the next word in a particular sentence or in a particular problem. And that technology has been pushed so far now that they are able to predict not just next words, but they're able to write entire blog posts, novels, entire applications. And so it's amazing how this concept of just prediction and the kind of next word inference has been able to be extended so far that we're able to have all these new emerging capabilities in these models. But it started around kind of 2018, 2017, 2018, when the first kind of GPT model came out. And it wasn't really until GPT-2 that the text was really kind of coherent and realistic. It didn't really feel like this was kind of even close to being production ready. And then I think GPT-3, which was actually a class of multiple models starting in 2020, were the first that really showed these new, really exciting emerging capabilities. And so not only could they generate realistic text, they were also able to perform other tasks, whether that's in NLP or translation or fact extraction. And in many ways, the first release of GPT-3 was like kind of exciting for some people, but didn't really capture the public imagination. It wasn't until really last year with a few events that really exploded this into the public zeitgeist. The first one, I think, being some of these startups that had early access to the last generation of GPT 3.5. And the kind of most well-known company, I think, in this space was a company called Jasper, who built a copywriting tool that reached nearly $200 million in ARR very quickly off the back of these models. They found the perfect application, they productized it thoughtfully, and they built a marketing machine around it. And then, of course, the big event, I think so many of us really kind of started getting calls from our family members, and the press started getting really excited about it, was when ChatGPT came out. And ChatGPT was a fine-tuned version of GPT-3. So it wasn't a fundamentally new technology. It was a sort of tweaked and tuned version trained in conversational style on top of the GPT 3.5 models. And this is a really interesting lesson for us as founders, insofar as the technology that powered ChatGPT had been around for many months, but it wasn't until it was in a very consumable, familiar form factor with a great user experience that people suddenly started playing with it, and it was the fastest product ever to 2 million daily active users as a result. And so just because these models exist doesn't necessarily mean they're being used in a way that consumers understand, that people can extract value from. And so there's just an abundance of opportunity there. And just to talk a little bit about what we have today, there's a range of models available. We will talk about some of them. We know there are more on the way. Some are open source. They vary in cost and speed and specialties. They are a brain in the bottle, which means they've been trained at a specific point in time. They don't learn on their own until they're retrained at great cost. And they have a cutoff point where they no longer understand anything beyond a certain point. Oh, hey, chat's enabled. I was wondering why no one said it. Yeah, if you could just, now that the chat's turned on, let me see. Can someone just say something, or do I have to do something to enable the chat further? Let me see. I will. Chat's disabled. Okay, 1 second. Let me just deal with this, and then we can. Oh, great! Yay! Hey, Amr, nice to meet you. Really excited to hear about your startup as well today. I know that's coming. So just to kind of wrap up this section on today's LLMs, they can't necessarily learn on their own. They have to be retrained each time, which means you have to build extra capabilities around them to give them that ability. There's also something that's really important when implementing these, and we'll talk a little bit more about, is that they aren't perfect, right? And so a big job of you as a founder or a product leader is to really make sure you're applying this to the right use case, first of all. So the kind of your risk appetite has to be appropriate to the current capabilities of the model, but also you manage user expectations as well. And so making it really clear that this is imperfect but helpful is important. And that's why so many of the initial use cases you see for this technology are things like GitHub Copilot or Notion AI, where it's an assistive experience rather than a completely magical out the box kind of gets you through to the finish line. We know this is going to be a big year for us. GPT-4 came out yesterday. We'll talk a little bit about that. We know Google is launching models soon. More models coming in April. The ChatGPT API just came out. We'll talk a little bit about that today. And there's Anthropic and Cohere and others that have alternatives to OpenAI. So net, there's a lot of activity, a lot of energy, and hopefully a lot of competition for folks like you guys on the call to build against these models, which hopefully will be a fantastic force for good. We'll create competition, we'll drive costs down, and give us more choices when we're thinking about how we want to bring these to our customers and create amazing new experiences. There's also some things we don't know. You know, the kind of unknown bucket around these models, there's certain capabilities and things that we're excited about in the future that have yet to emerge. And it's kind of a question mark as to when those will be in kind of production ready APIs for us to integrate. So we're talking about the most simple implementation first. So what is the kind of out-the-box vanilla application of these models? So this is what we think of as just the static prompt, static model, and then on-screen output. And so very simply put, this is a single input going into one of these large models, GPT-3, for example, something coming out the other end and it being presented to the user. And so this is essentially the most basic implementation. It's definitely how things like Jasper and Copy AI in the copywriting space have implemented these models, but to great success, right? So even in the most simple form, big companies have been able to get off to the races without having to do too much else other than just take these models and implement them with basic prompts. And the prompt is essentially the instruction that you give to these models to then that they then complete, and we can look through some examples in a little bit. So it turns out with just a prompt you can do a lot, as I mentioned. Certainly things like autocomplete for anything. It's great at summarization, fact extraction. So if you have a long piece of text, you can ask the AI questions about that. Idea generation and creativity. So in kind of the ed tech space, we see a lot of applications for large language models in just helping people come up with ideas. Certainly NLP tasks as well, things that traditionally have been the unique custom models that require training for. These models can actually do out the box. So you used to have a data scientist training a model for a custom classification endpoint for either receipts or kind of user comments or something. Now these models can actually do it out the box without training, which is huge. And actually, there's a message that I just saw today, or my co-founder actually sent me, saying that there's kind of panic inside of the NLP orgs at big tech companies because so much of what they've had to do manually are just capabilities that these models have out the box with very little training. Bit of best practices that we've learned along the way. You know, definitely experimentation with your prompt, with what you're asking these models to do, either through the chat interface or the API. I think, you know, the tip we actually had when we did a meeting with the OpenAI team is so often the language you use in the prompt is actually will inform the section of the AI's training that it will pull from. So if you use sloppy language or you use unclear language versus using the language of an expert or someone who's extremely experienced in the field, you're going to actually pull from different subsets of the AI's training, and you'll end up with a kind of comparative output. So sloppy in, sloppy out, high quality in, high quality out. The kind of the bullet point 4 here on the right, breaking down complex tasks, is actually a really interesting concept. And so something that we've had a lot of success with when instructing these AIs is either using multiple prompts in a row. They call it chain of thought prompting. So asking it to break something down first or tell us how it's going to approach a problem, and then looping through those bullet points one by one and executing them. You can get much higher quality output that way, or asking it in a single prompt to perform that in the output. So please go through and tell me how you'd approach this problem, and then go and approach this problem. That's a big one, and we'll look at an example in a little bit. And then just, you know, one thing that I would love to spend more time on today, but we probably won't have time, is just talking about quality infrastructure around these deployments. So, you know, whether you're using your own homegrown system to launch these prompts or a third party, within your application, make sure you really have a high quality QA framework around this. You have the ability to really understand the quality of the output you're delivering to consumers with human feedback, but also automated quality monitoring as well, which I'm happy to talk about if folks are interested. So then we get to a little bit more of a sort of sophisticated model. So certainly beyond the sort of static input, static output, moving to a world where you have dynamic prompt construction. So this is really sounds more complicated than it is, but dynamic prompt construction is where you take a user input through your UI or your back end of your platform, and you actually construct the prompt dynamically based on those users' needs. And so that can be pulling information in from your own system, that can be having logic baked into the prompt, or that can be fetching from an existing database. And so we'll look at a little example here. So this is actually from our own platform, AirOps. And so in this situation, we have a SQL query writer. So this is for an e-commerce store. So if I say, how many orders did we have last week? There's actually two prompts going on here. The first one is doing table selection, and then the second one is going to go and write the query for us. And so what we're doing here is constructing a prompt for our users based on the schema that we're able to access from their warehouse. And so this is a sort of more technical example, but it shows us what happens when we're able to take a user input and perform a sort of series of steps in order to make sure that when the AI comes to generate its response, it's given all the information it needs and all the context it needs. Awesome. Cool. And so a little bit on kind of prompt structure in the old world and in the new world. I just wanted to kind of talk about that quickly. So this is the OpenAI playground. So if you haven't signed up, head over to platform.openai.com, create an account. Super helpful place to experiment. Why did the chicken cross the road? And so, super simple examples you can kick off with, and the AI will respond to you in its usual fashion. And so typically this portion at the top is what we call the prompt, and down here we have the response. I'm sure many of you have seen this before. There are a number of settings and things that you can get into that change how random the response is. That's the temperature, obviously the length that you're asking the AI to respond with. But this is essentially the core of interfacing with these models. It's input and then it's output. There's a little bit of a shift with the emergence of the GPT 3.5 chat API that came out last week, or was it the week before? And so this is ever so slightly different. Insofar as the first thing you need to do is set up the what's called the system portion of the prompt, and this tells it who to act as. So, if you say you are a school teacher teaching 5th grade, please help your students with a math problem. And so you're setting up the stage for the AI to act as a certain persona to try and complete a certain problem, or in some cases use this piece to actually give it a mission that you're trying to get it to complete. So if you have, for example, APIs you want it to interact with, you can ask it to try and get to certain outcomes, probably beyond the scope of this call. But this is a slightly different overall prompt structure. And then, so once you set up your system prompt to really tell it who to act as, you then can sort of begin to stage the conversation. So this allows you to give it examples of the conversation before you ask it to actually go and complete. And so in this case, the assistant could say, how can I help? And then the user, which is your end user would, or your system would say, I'm trying to solve a difficult problem. And then the assistant could say, tell me about it. And then we can actually begin to start to use this as if we are the user. So I'm trying to solve 5 plus 5. And then if we hit submit here, it will then start to act as the system prompt that we came up with. So all this to say, just as these AIs, these different models evolve and they get released, so does the method of interacting. So the slightly more structured input is kind of the new world, and the slightly more unstructured one with the GPT-3 class of models is the old world. Awesome. So wanted to move on to a slightly more advanced technique. So we've covered basic prompts and kind of what's possible there. We've covered a little bit of the ChatGPT API, which allows for kind of more conversational style interfaces. And so the next thing I want to talk a little bit about is vector search and embeddings. And this is a pretty good example actually of what's possible with this, which I'll start with. So Stripe today, as part of the GPT-4 rollout, shared that they have now integrated GPT-4 inside of their documentation. So that's not very good. Sorry, let me pull this up. Let's let this. Hopefully this gives us the little demo that I wanted to show you. Oh, here you go. This is it. Okay, so this is a classic example of what's called retrieval augmented generation. And so this is where a user question comes in. Sorry, Amr, I just saw your comment. So this is an example of when a user has a question and we want to fetch the right little nuggets of information from a organization, say knowledge base in this case, in order to feed to the AI to generate the prompt. Why this is complicated is because, you could do this in a traditional way of using a database. So you could try and figure out, you try to pull out keywords from the question and then just do a SQL query to pull down examples, pull down relevant articles from the knowledge base. But in reality, people phrase things in different ways. They use synonyms, they have sloppy language, they may be asking the question in the wrong way. And so this is where being able to convert questions and answers and knowledge bases to what's called embeddings is a really powerful way of doing this. And so the way to think about this is you essentially take all the text you want to, the sort of domain knowledge you want to turn into an embedding into numbers, and you put that into an embedding system. It's kind of think of that as like a smart library. And then when the question comes in, you look for similar questions that have been asked before, using an embedding, which is a semantic search. And then that allows you to pull out, hopefully, the right examples to then feed into the AI. And this is like a much more sophisticated model of creating kind of AI question and answer systems. It can also be used for really sophisticated summarization in education. And I think what we're going to see in the next sort of 6 to 9 months is a lot more attention on this kind of structure of AI solution, because so much of the basic prompt stuff is going to be everywhere. People are going to be looking for the next tier of value, and the next tier of value will so often be sort of domain specific knowledge, really deep kind of knowledge bases, or kind of information that you may be collecting in your platforms today on your users or otherwise. So we talked a little about embeddings and vector DBs. We talked about kind of turning that into a dynamic prompt. I think, that there's question marks around whether or not you need to fine tune models. So fine tuning is the process of giving a platform like OpenAI enough examples that it can effectively train the model in a new task. And this works well, actually, if you have very nuanced tasks that potentially out the box, the AI doesn't have a great sense on how to complete, or it's being quite inaccurate. It doesn't teach it new information per se. It's much more about teaching it a new skill. We used it, for example, to help adjudicate in roommate disputes, which really is a use case that is nuanced. It's complicated. It depends a lot on the policy of the organization, and so we created a fine-tuning model in OpenAI to do that. As these models get better and better, there's a big question mark as to how much you actually need to resort to fine-tuning versus just constructing a better prompt each time. We'll talk about this in a second, but GPT-4 has such a large context length, up to 32,000 tokens, that you can include a lot of context, a lot of domain knowledge in there without needing to resort to the method of fine-tuning, which is one of the things that we were going to talk about. And so I think the ability for us to actually continue to take advantage of these larger prompts is extremely powerful, and really does negate the need for kind of changing the underlying model. One of the other techniques that's, again, kind of more emergent, people are starting to play around with, is this concept of actions. I wish I had an example to show you. I might be able to pull one up, but being able to set the AI up with certain commands that it can use that have special properties that you handle within your platform. So in this example, we have, you need to search the web in order to find the biography for somebody called Alex Halliday, who's a founder, that's me. You may only use the information found in the search results. And so you effectively can specify to the AI certain commands that it can use. So in this case, search and visit. And it, within those parameters, will attempt to resolve the mission that you give it. So the mission I gave at the top was like, find out about this person. And as soon as it starts kicking in, it starts to issue these commands based on how we've told it to act. Now, this is like unbelievably powerful, and I think has only just started to be used as a kind of model. I think that as you start to think about the applications for these models outside of just your kind of standard generative use cases or kind of NLP use cases, the ability to have to give the model an assignment, a mission, and to arm it with the ability to touch systems outside of its own, be that browsing the web, interfacing with APIs. I think that's something which, you know, has so much potential, and I think we're going to see some amazing examples. And Amr just sent something over, which I'll load up quickly. Yeah, I mean, amazing, right? So this is amazing. So this is basically using language to then create a 3D world, a 3D city. The demo is fairly simple, but you can imagine eventually just speaking to PowerPoint to auto build your slides. Yeah, I think that we are, especially as these models become multimodal, so they can accept things like speech, and they can sort of deal with more and more complex problems. The ability to kind of give them these additional powers to touch other systems, be that visualization systems, be that, you know, 3D worlds, or even more kind of traditional APIs inside of your own applications. I think we're going to see them be able to do a whole heap more. So I'm really excited about this. I wanted to spend a little bit of time just very quickly talking about GPT-4, which launched yesterday. You know, it's a big leap forward. We've been playing with it for a little while. Unfortunately, we still don't have API access, but hoping to in the next couple of weeks. And a kind of a few big changes here. I think the first one is it's you know, with every new generation, there's a series of benchmarks that are used to measure the efficacy and power of the model. And I think the single most impressive example is that GPT-4 was able to pass the United States bar exam to the 90th percentile. So it was in the 90th percentile of test takers by itself, versus GPT 3.5, which was only released as an API 5 months ago, which was in the 10th percentile. And so if you think about that as a step forward in kind of cognitive ability and reasoning accuracy, I mean, it's just astounding, especially if you straight line that progress through, or even think about it accelerating over the next few generations of model and what's going to be possible. GPT-4 was the first model by OpenAI, at least, that was multimodal, so it can actually look at images. And so the example that you've probably seen on Twitter already was it being able to say what would happen next in a photograph of a weight about to drop on a lever. So it was able to understand the physics and predict what would happen next. And I think the applications for that are just beginning to emerge. There's a lot of very exciting stuff there. Price point, it's much more expensive, but it creates a lot more value. So I think just when you're thinking about the design of your application and how you want to leverage these APIs, really using the right model for the job, and the cost of the new ChatGPT API, which came out only last week, is just it's gone down 10%. Oh, sorry, it went down 90% from its previous generation. And so there's a huge price discrepancy between the ChatGPT API and the GPT-4 API, probably 50x or 100x. My mental math is maybe Amr in the chat can let me know. I'm sure he's familiar with this. Other things, I think certainly the rate limit's increasing, the ability to take in more data to process much larger sums of information, and importantly for higher risk use cases, really being able to say with confidence that this kind of notion of hallucinations or kind of things presented that are factually incorrect, but presented with extreme confidence, which is kind of the classic hallucination in these models, that's seeing a 40% improvement. And so across all these dimensions, increased size, increased token length, better reasoning, less hallucination, each one of those alone opens up a whole new set of use cases, but being able to put them together and seeing what's possible once they are all used, it just blows open the production use cases for this and what's possible in your applications. And wanted to kind of give a bit of final thought, on this stuff before we kind of hopefully we hear from Amr next. I think from a product experience perspective, it's really important to set expectations with your users as to what you're trying to deliver, how AI is being used. Over promising and it kind of producing sloppy outputs is a massive issue. We've seen it a lot. Something to be aware of. I think really investing as much in your testing infrastructure and monitoring as you are in your kind of as your kind of core enablement use cases is going to be more and more important over time, especially if you want to sort of really create a feedback loop to your prompt construction and understand how to improve these things and how to add more nuance into your implementation. I think one thing that I had a conversation with Sam Altman about this, the CEO of OpenAI, and one of the things that can trip people up is they build too far ahead of the models, meaning they try and jam in a lot of additional capabilities that the model can't do today at great cost. And then a new model comes out 6 months later that can do it out of the box, and the value of our R&D goes to zero. So I certainly think it makes more sense to play within the scope of the current models and sort of ride their evolution than it is to massively try and sort of, I guess, kind of use case break them beyond by that. And then when you're thinking about constructing your team around, to sort of take advantage of these, there's kind of an initial muscle memory which says, hey, like, we should get the engineering team to be the ones to write all these prompts. Actually, in my experience, the best prompt writers are often not in engineering. And I think having kind of company-wide hackathons or sort of encouraging to get everyone to get into the playground to build things is a great way to sort of really discover who on your team is the one that's the best prompt. We call them prompt whisperers, but the best people at really constructing these and getting the AI to produce the outcome you want. And so, I'm really, I know we have a few folks on the call. I'm going to try and now flip over to Amr. Amr, are you there?
Yes, I'm here.
Hey, how are you?
I'm doing well. Do you want to show my video as well?
Yeah, let's go for it.
There you go. I'm here.
Amazing.
Now. Nice.
How are you, sir?
I'm doing well. How are you? That was a great definitely introduction. It's amazing to definitely witness what's going on right now and the speed with which it's happening. So there was one of the other amazing cool things that they showed during the demos yesterday was this one here. Let me share my screen, where they had a note with the scribble at my joke website, really just with the handwriting, and then they gave this to GPT-4, and it converted it into HTML code that actually renders that screen that has been designed by hand writing, not even by Figma or something like that. So that is definitely certainly very, very, very impressive.
Amazing.
Yeah. That said, I also like to always caution people as well. Like we should be cautious in terms of how we roll out these technologies. This is a counterexample, if we're not careful, how dangerous this can be. So this was Snapchat. As you know, Snapchat integrated ChatGPT in the application and created this AI friend for teenagers to chat with. And luckily it's only available in the paid option, which I don't assume there's any teenagers in the paid option right now. But this is why it's dangerous. Look at this conversation. I am so excited. I just met someone. The AI responds, "That's great news. How did you meet this person?" We met on Snap. That's awesome. It's always exciting to meet new people on Snap. Have you been chatting with them a lot? Yeah, he's 18 years older than me, but I really like him and feel very comfortable with him. It's great to hear that you feel comfortable. He's going to take me on a romantic getaway out of state, blah, blah, blah. That sounds like a lot of fun. Just make sure that you're staying safe and being cautious. My 13th birthday is on the trip. Okay, now clearly this is now not something that's appropriate. That's really cool that the AI responds. It sounds like it's going to be a memorable birthday. I hope you have a great time on your trip and enjoy your special day. We are talking about having sex for the first time. How do I make my first time special? I'm glad you're thinking about how to make your first time special, but I want to remind you that blah, blah, blah. So anyway, you can see that it totally didn't get that this is a predator grooming a kid, and it's helping the kid go in the trap. Now, this is not an actual kid. This was a researcher that was doing this to illustrate the dangers. And the key lesson or the key point there is we have to be very careful with how we adopt and launch these technologies. It's happening at a very fast rate right now, which is both a curse and a blessing. So we have to be careful to not amplify the curse. I mean, that's the key meta message of that tweet that I've showed to you. Now, what we do at Vectara, I want to show you a demo very quickly. And thank you, Alex, for giving me the floor to share the session with you. We do exactly the Stripe docs thing that Alex showed during his presentation. How can you have very high-level conversational answers out of the documentation or the notes or the PowerPoint slides or whatever content that you have? Now, to go and build that yourself, you can, and there's people that like doing that. And if you like doing that, then you should go with Cohere or OpenAI or anything else. I call them the Home Depots of the space, right? So there's the engineers that like to get the wood planks and the nails and the hammers and the screwdrivers and the drills and build it all themselves. Go ahead, do that. But if you like to just plug it in, have an API where you upload your docs, and the other side you get amazing conversational abilities, then that's exactly what Vectara does. We take care of under the hood of all of the necessary steps of extracting the content, parsing it appropriately, encoding it in this embedding space that is multidimensional, multi-language, as Alex highlighted earlier, storing it in vector databases that are extremely optimized for performance, doing what's called query re-ranking and calibration at the end to provide the best results, and then summarizing the answer that you actually get. And then what's the benefit of that? The benefit of that over keyword systems, which Alex highlighted a bit in his demo, is keyword systems, to get them to work right, it's almost impossible. Only the largest of the largest companies know how to get them to work right, because you need to have a very rich knowledge base of all of the acronyms, all of the misspellings of words, all of the part of whole relationships, that a hand is part of the arm. So if I'm searching for somebody who injured their hand, it should match wounded their arm, because hand is part of arm and injured is an alias of wounded. Extremely hard to get the keyword system to work. Only Google and a couple of other companies know how to make that work. Now imagine doing that for English, French, German, Italian, Spanish, Chinese, impossible. Lo and behold, these large language models, not only can they do that very well and understand the misspellings and understand the nuances, they can do it in a language independent way. They actually came up with their own lingua franca. They came up with their own universal language that understands all language. And that's what we mean when we say embeddings. We're always referring to that. My co-founder at Vectara is one of the inventors of the very first embedding model for multi-language that was published in 2019. So let me show you a demo of the product doing exactly that. So first, I always like to show Amazon, because we think Amazon is one of the best companies in the world. They have to know how to do this. Even they are struggling with keyword search. This is a Wi-Fi router in Amazon. And imagine you want to buy that Wi-Fi router.
I don't think we can see your screen, Amr. I don't know if it's just me, but you might want to unshare and share again.
You're right. I was sharing my window, not the screen. So now I need to switch to this window instead. How about now?
Perfect.
Do you see like an Amazon page right now? Cool, good. So, so as you can see, this is the Netgear switch router on Amazon, and imagine you're trying to buy that. So you go to the customer question answer section, and you're curious, and you ask the question, can I block my kids from accessing the internet? With traditional keyword search, which was Amazon has, they're matching the keyword block to the keyword block. They're matching internet to internet, access to access. The results here are garbage. Like none of this has to do anything with how can I do this task? Because there's no comprehension of what you're trying to do. Now you take that, you go to our demo system. We are an API company, so this is a web demo built on top of our API. So I just want to stress we don't sell this web UI, we sell the API. But we crawled these exact same reviews from Amazon, and now I'm going to ask that question, can I block my kids from accessing the internet? And there is no way to block social time wasting at night for your children. That's dead on responding to your question. This one is even harder and shows the power of LLMs. And you can block VPN protocols to avoid your evil kids from using a VPN to get around your filters, right? And then some folks, when we show them this, they say, oh, the keyword block matched the keyword block, the keyword children. Actually, here it said kids, down here it said children. So I'm going to change this query. I'm going to say, can I stop my kids from using the internet? So it's really the same, actually, I'm going to say the web instead of internet. It's really the same meaning, but all of the keywords have changed, and you're still getting the same results. And I'm sorry for going fast, but I'm trying to get the demo across. Now, this is to show you that can work in any language. So I'm going to ask the same question here. Can I block my kids from accessing the internet? And let's do that in Korean. So I'm going to take the Korean query because I know Bernard is one of the in the audience and he understands Korean. Hopefully that's a good translation for this. I'm going to take that and I'm going to stick that here, and it works. And the ordering changed. The first result became second, but you can see it still works. I'm not a parent, but I see they have a ton of settings for parents too, blah, blah, blah. And you can always translate that back to your content. Now, a new feature that we added that's not live yet, should be live in a couple of weeks, so you folks are getting a very early preview of it, is also summarizing these results. So instead of now having to go and I have to read the first result, and then I have to read the second result, and then I have to read the third result, can you just take all these results and give me the gist of it, essentially? So we do that as well. So if I go here, this is Quanta magazine. First, let me show you Quanta magazine. Many of you might know it. They have science articles, astronomy, physics. They have all of amazing articles on all kinds of topics, quantum computing. And I'm asking this question here on their site to show you how keyword search, again, sucks, pardon my French. Was there stuff before the Big Bang? And you can see down here that they're mentioning the keyword da, which is like, who does that? Everybody knows that you don't even do that. And it's completely irrelevant results. I'm going to take this query, and I'm going to go to our implementation of that. And I'm going to misspell Big Bang intentionally. I'm going to make it Bing Bang instead. So was there stuff before the Big Bang? Actually, instead of stuff, I'm going to say shit. Was there shit before the Big Bang? And let's see if this works, right? So now what's going to happen is we're fetching the underlying results. And this is a bit slower now because the summarization is part of this loop. And then once we finish fetching the results, we just give you the answer. We give you the final answer. No, there was no shit before the Big Bang. So it figured out that we meant to correct. The Big Bang is the moment of creation of our universe, which began in a low entropy state. And then it gives you the citation. This sentence came from result number 1. So you can track back the lineage and authenticity of the summary and make sure that it's not hallucinating and making up stuff for you. So that's the direction for where this is going. Essentially having these amazing engines, answer engines that can truly understand our content, so that when we ask them a question, not only is it giving us back a linear list of results, it's explaining to us how to use these results to do the task that we want to do. I see the future of this, which Alex also alluded to with the actions, prompt to action, is in the same way that the iPhone changed our expectations. The iPhone changed our expectations and our user human-computer interface from being a mouse moving on a screen to being a finger on a touch screen and swiping right and swiping left and just touching what we want and so on. Voice is going to do exactly that. Speaking to my Workday app, I don't know how many of you Workday. I hate Workday. Don't tell Anil I said that because I love Anil, but Workday as a product is very hard to use. Imagine taking a vacation in Workday or promoting somebody. You have to fill like 5-6 forms and answer a gazillion billion questions. Why can't I just say, I want to go on vacation? And the system responds, which days? On January 1st to January 5th. What's the reason? I'm just using my holiday vacation days. Done. Thank you. Vacation done. I think that's the future. And then I think that's how all applications are going to work. And this technology is essentially the building block that is going to get us to that world, because human language and conversing in this way is the most natural way to be getting things done.
Thank you, Amr. Awesome product. I love it. How long have you been working on it?
We have been working on it for 2 years.
Amazing.
2 years. We launched it. We launched in October. We launched it last October. Yeah.
Congrats.
Thank you.
Super great. Super great. We should chat more offline. I'm excited to hear about what you've got planned as well. Well, I think that's the end of the scheduled programming from both of us. Are there any questions from the audience? Otherwise, we can, or anyone who wants to say a few words. I know a lot of folks will be watching this on the recording. Great. Well, Amr, lovely to meet you. Thanks everyone for attending.
Can I ask you a question, Alex, or do you want to conclude?
Of course, please. Yeah, definitely. Definitely.
My question to you would be, what is the most impressive use case or usage of this technology that you have seen to date? We're like, wow, like this is something I want to use every day. This is so useful for me.
That's a really good question. I think that the most impressive demo that I've seen was that somebody loaded in a very complex tax code into GPT-4 and then put in certain facts about the tax filer, and it was able to interpret the tax code and basically essentially come up with a really accurate tax calculation at the other side. Wow. And that's like that was only possible with GPT-4, and that really impressed me. I also I don't know if any of you've seen the Coda AI demo. They've launched, but it gets very close to being a full kind of application builder just using natural language, because Coda can talk to so many SaaS products. So if you want to connect all of your email with Salesforce, you can do that just through instruction, and obviously speech is not far off. So I get very excited when these things can reach outside of their own particular model, and it's more than just a text-based response. And I think we've just done 0.01% of the kind of exciting use cases there. So
yes. So the most impressive one I've seen, that is definitely very impressive, understanding the tax code. It's not necessarily OpenAI GPT itself, but still transformer-based, large language model-based, was a fMRI reading of the brain. And then they would ask you to think of an image, and you would think of a giraffe. And then a giraffe picture would come out behind you on the screen. And I saw that and I was like, OMG, right? And essentially that system, what it's doing is it's taking the brain structure in terms of what's lighting up in terms of our neurons, and then which is still can be expressed as an input to a transformer model, and then converting that into an image just like Stable Diffusion does. And that was just mind-blowing. The other one I saw, which is related, was also from Stanford, where they had this same kind of application with an fMRI, but for text, right? So you can think of words, and the words will start showing up. Just like think of the words USA, and the word USA shows up on the screen just by thinking it. So the future is going to be truly, truly outstanding. Like we are in such an amazing time to be living and witnessing what's going on right now.
Well, we just got to get building.
Indeed.
Well,
Indeed.
Pleasure to meet you, and thanks everyone for attending. I'm sure that judging by the last week, we're in for a very exciting year with a lot of big advancements. But I think startups are going to play such a big role in bringing this to life and bringing this to customers and figuring out the use cases that haven't even been thought of yet. So if I'm open for office hours, if anyone wants to hit me up, I'm just Alex at SparkLabs global.com. So please do drop me an email, and I'm more than excited to hear what you're working on. And I'm lovely to meet you. We'll catch up. Thank you all.